So we're going to be doing a little preview of Unit 7. Now, Unit 7 is all about volume. However, in order to do volume or how much something can hold, we first need to talk about area. Now, a lot of these area formulas should not be new for you. And there's three main ones, technically four, that we're going to be talking about. The fourth one is dealing with something called area of a regular polygon, which I'll talk about what those are in a moment. But the other three main are a rectangle, triangle, circle. Technically, for a rectangle, it is also a parallelogram. So for area of a rectangle, it is base times height. Notice how I'm using lowercase letters. Sometimes you see the area of a rectangle formula being length times width. It's the same thing. For a triangle, we still have our base times our height, but then we need to divide it by 2. And then with a circle, since it is a round shape, we have to use our pi button. Up until this point in time, you guys have been using 3.14 as pi. But since that is an estimate of pi, we're not really going to use it. Because on our graphing calculators, we have a pi button. So for area of a circle, it's pi times r squared. R is our radius, or the distance from the center of the circle to the edge of the circle. So let's look at some examples. First, example 1 is a triangle. I know it has 3 sides. However, I have a bunch of measurements in this triangle. And we need to figure out which one is our base and which one is our height. Well, if we think about when we go to the doctor's office, for example, we know that when we get our height measured, we stand perfectly straight up and down. In other words, at a 90-degree angle. So that's what I look for. I want to see if I see a 90-degree angle. In fact, I do. I see that this section is at a right angle with that section. So that tells me those two numbers, the 10 and the 5.6, are my two numbers. So I know my area for a triangle is our base times our height divided by 2. Or in this case, area is 10 times 5.6 divided by 2. And if we type that in the calculator, we end up getting 28 for our answer. However, we kind of want to deal with units of measure. Unit of measure in this is a kilometer. So it's kilometers, and area is squared. In example 2, we have a circle, a round shape. So that tells me its area equals pi r squared. Or in this case, area equals pi times 6.2 squared. So let's type that in our calculator. Our pi button is above our caret, but it's in blue, so I need to hit second, and then I'm going to hit my pi button, then times 6.2 2 squared. And if I hit enter, I get 120 area equals 120.763. Once again, unit of measure though. Our unit of measure is in miles, so it would be miles squared. Again, please remember area is squared. Example 3. Example 3 is actually a parallelogram. So we're actually going to use the same formula that we did for a rectangle, base times height. So my area equals 5.9, or base times height, or in this case, 5.9 times 4. Typing that in my calculator. So 5.9 times 4 gets me 23.6. Units of measure, you have inches, so it'd be inches squared. And the last one, we have a rectangle. So it's the same formula. Area equals base times height. Or in this case, area equals 5 times 7. So 5 times 7 is 35. So my area is 35 units of measure, inches squared. So these three shapes really should not be new. So sometimes we're going to need to know the name of a shape in order to figure out what the formula to use. So up until this point, we've been dealing with triangle, or a shape with 3 sides, a rectangle, square or parallelogram, which has 4 sides, and a circle which has no sides. But now we need to find something called area of a polygon. So what a polygon is a 2-dimensional shape with straight sides. So remember, area and all the stuff that we're dealing with right now are a 2-dimensional thing. We can draw it easily on a flat surface. It does not matter. However, we have multiple different types of polygons. But they fall under 2 categories. First category is a regular polygon. Second category is a irregular polygon. What a regular polygon is all sides and angles of a polygon are congruent. So all of our interior angles, all the angles inside of the polygon are congruent. They're the same measure. And all of our side lengths are the same measure. So that's what a regular polygon is. What you guys think an irregular polygon is? Well, an irregular polygon, all sides and angles of a polygon are not congruent. Now, before we move on to the examples, these shapes, based on the number of sides, have particular names. For example, we know a shape that has 3 sides is called a triangle. Now, there are other names for a 4-sided shape, such as, like we said, a rectangle, square, parallelogram. But the overarching name for all of them is called a quadrilateral. And a way we can remember this is tri, like a tricycle, means 3. Quad means 4. A 5-sided shape, in fact, there's a very famous one in the United States called the pentagon. Penta means 5. A 6-sided shape is called a hexagon. Hexa means 6. A heptagon is a 7-sided figure. Hepta means 7. An 8-sided figure is an octagon. Octa means 8, just like an octopus has 8 arms. A 9-sided figure called a nonagon. A 10-sided is a decagon, like a decade is 10 years. And a 12-sided figure is called a dodecagon. So dodeca means 12. Okay. So let's look at these examples. Example 5 wants us to know, well, how many sides. So this shape has 1, 2, 3, 4, 5 sides. So this is called a pentagon. Now the question is this a regular or irregular shape? Well, looking at it, does it look like all of our sides and angles are the same? Nope. So this is an irregular pentagon. Looking at number 6, we have 4 sides. So this is a quadrilateral. And then, does it look like all sides and angles are the same? In this case, it looks like it does. So we will say that this is a regular quadrilateral. Example 7, let's count the number of sides. We have 1, 2, 3, 4, 5, 6 sides. So this is a hexagon. And does it look like it's regular or irregular? Well, considering the fact that I can look at it and see one side super long and the side right next to it super short, this is irregular. Take a moment and try to do examples 8, 9, and 10. In example 8, we have 1, 2, 3, 4, 5, 6, 7 sides. So that makes this a heptagon. And looking at the shape, it does look like it is regular. All of the sides look to be congruent. Example 9, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides, making this a decagon. and the sides look like they are regular. And then number 10, we have 1, 2, 3, 4, 5, 6, 7 sides, making it a heptagon. And looking at our side lengths, it appears to be irregular. We also know it's irregular because it has this little jut in it. It has a dent in it.